Welcome to Module 5, Lesson 14, Comparing Fraction Using Common Numerators. Now, this is an interesting way to look at fractions. It makes sense. See, by common numerators, what we mean is the numerator, the number on the top, is the same on both the left and the right. So, as you can see, both of these numbers have a 4 as a numerator. So that's the amount of slices, for example. 4 slices have been taken, and the denominator for each of these is different. The denominator here on the left says 5. So 4 slices have been taken, and 5 would make it whole. So there's just one more slice missing. Those are pretty big slices. Now in this one on the right, there are 10 slices to make a whole. Those slices must be a lot smaller than the ones on the left. Because if the same size pizza were to be cut into fifths, or the same size pizza were to be cut into tenths, and I'm not going to do all of them, but you can see it's going to take a lot more work to get tenths. So the pizza on the left is larger because fifths are bigger slices than tenths. So 4 are shaded here and 4 are shaded here. And look at how much more pizza on the left has been shaded than this little bit here on the right. So you can compare with numerators, and it tells you pieces are that were taken. So on the first several problems, that's what they're asking you to do. When you compare, the numerators are all the same on number 1. 1/3 and 1/6. Okay? So are thirds or are sixths bigger pieces? Well, thirds are. So a third is larger than a sixth. And they want you to reason about the size. So I'll just type in here. Thirds are larger than sixths. And that's all they're asking you to do. Thirds are larger than sixths. 5/8 versus 5/10. So, I'm looking at this one, by the way, right here. So I would much rather say that the eighths are larger than tenths. Halves and thirds. Halves are larger than thirds. And you're going to want to just keep using the reasoning to explain why. Now for number 2, the directions are very important because it says you could explain your thinking using words, pictures, or numbers. So there's a lot of ways to do it, and you could look at B. It's been done for you. They drew pictures, they have reasoning, they've done a lot of things to explain which one's larger. So you could draw. You could go ahead and do the drawing twice, and you want to color 3/6 on the top one and 3/7 on the bottom one. The only thing about drawings is they're not always accurate. So 3 here versus 3 here, just barely you could tell that the 6ths are larger than the 7ths. And your reasoning here is by drawing a picture. Okay, you could do some other options, like saying on D, for example, the numerators are not the same. 5 versus 10. I'd have to double this one to be a 10, and whatever you do to the top, you have to do to the bottom. So if I doubled the 5, I have to double the 7, which is a 14. Now what's larger? 14ths or 13ths? They're very close fractions, but 14ths, since it's a higher number, it means more pieces, so they're smaller pieces. So therefore, 10/13 is larger. And you could say 13ths are larger than sevenths or larger than 14ths. Now, moving on, kind of a little bit of a different spin here. They want you to compare using related denominators. Now, why they switched to denominators, I have no idea. That's actually the next lesson. So they want you to go ahead and draw 2 tape diagrams, one for each of these, and they want you to compare. So they want you to take the 3/4 and the 7/12. So the 3/4 could look like this. And then you could pause the video if you need to for a little bit, but then you could see on the bottom I drew 7/12. Now I've drawn both fractions, and I tried to draw them as accurate as I could in same size shapes. But there's a part I'm missing here. They want related denominators. So instead of common numerators, now I want common denominators. I want the numbers on the bottom to be the same. If this is a 4 and this is a 12, how do I make them the same? I can turn the 4 into 12 by tripling it. So they just want you to draw some lines to triple the amount, triple each piece. And so now you can see you have 9/12. If you were to look at these shaded areas, there's 3 in here, there's 3 in here, and 3 in here. Did I do that right? There we go. Over on the edge here. 9/12. So if this was really a 9/12, and this was a 7/12, well, 9 of them would be more. And you can see that in the picture, that it's clearly a little bit longer than this one, right? So on the bottom B, I'll just tell you right now, I'm not going to do the whole thing, but on B you'll want to double the 4. And on C, you're going to want to draw a whole and a fraction for each one. A whole and a fraction piece to do the mixed. And you're going to want to double this so that it's 6/10 compared to 4/10. And of course 6/10 is going to be more. Alright? Then you can press the wrong button there. Then you continue to the next stage where they want you to draw a number line for each pair of fractions. So when they say that, they mean like one number line for each pair. So first, draw 3/4. So the 3/4 would be here. And now turn it into eighths, 5/8. So cutting the fourths into eighths, you'd put a line in the middle of each one and count over 5. 1, 2, 3, 4, 5 right here. So 3/4 is just a little bit larger. Okay? Let me do one more of those. Here's fifths, 4/5. Ooh, pretty awful. Sorry about that. 4/5. Hop over 4 times. 1, 2, 3, 4. That is not fifths. That's why it looks so awful. There we go. Wrong button. 1, 2, 3, 4 out of 5. And then you want to make tenths, which is double the amount. So you're going to want to put a tick mark, a hash mark in between each one. And now count 7/10. 1, 2, 3, 4, 5, 6, 7. Again, right before it. Definitely 4/5 is just a little bit larger. And then finally, at the end, you could compare and draw a model if you choose to. So you could do cross multiplication. 7 times 1 is 7. 7 times 2 is 14, and 14 is larger. So I would choose that method to compare. But of course, you could double the numerators, or you could match the numerators, you could match the denominators. You can turn the 7 into a 14 by doubling it, turn the 5 into a 10 by doubling it, and now 10/14 is less than 11/14. Alright? If you have any more questions on lesson 14, then see me and I'll be glad to help. Thanks.